Hello, in this video tutorial, I want to teach you how to make a power bank for your modem so that when you can keep the modem on and access the internet even if it is disconnected for a short period of time. Well, you know that wherever you live in the world, you may experience power outages for various reasons. The piece becomes annoying when you are dealing with the internet and you are doing something and you are connected to the internet. Well, you know when the power goes out. The phone or the phone line doesn't go down and there's no problem with it. And it's the modem that turns off because it runs on electricity. And then we can't access the internet. Although there are alternatives, such as an internet phone that you can use as a hotspot, it may not always work, because our target here is home. Modems are modems that are connected to the internet via telephone lines or a gel cell and the like. Even fiber optic internet has its own modem. So what if we want to use cable into the modem? It doesn't matter if we connect via ADSL or using Wi-Fi. In any case, we were connected to a broadband modem. But now that modem has been turned off due to a power outage, we no longer have access to the internet until the power comes back on. Well, you might say that we can wait for the electricity to come back, but this is not suitable for everyone and everywhere. As mentioned, maybe you have a very important job and are working with the internet. So by making a suitable power supply using the same power bank you have in your hand, and for your mobile phone, you can charge your modem when the power goes out. Keep it on, even if it's just for half an hour or an hour. That's how long you can keep it on. I'll tell you how to increase the time it stays on if it's not burning. So what do we need to build such a power supply and circuit? The first thing we need is a suitable power bank, which we see an example of here. I suggest you use power banks with air. High amperage, for example, the minimum amperage that a power bank should have is 2 amps. But the higher the amperage of a power bank, the higher the amp hour. It is the longer it will keep the modem on, so choose 2 amps at the very least. Although power banks have come up with 10 base amps, which are great, and I suggest you even use them, so in general, you need a power bank. Now, whatever model it is, it doesn't matter. Our goal is a power bank, which I brought here for the sake of a 2 amp power bank. A DC to DC converter module, which is actually a voltage booster. You need a USB socket. I wrote the model here, and you can get this model from our website, which I put the website link at the bottom. You need a USB socket. I will tell you what the purpose of this USB socket will be and where we are going to use it. Now we are going to build my circuit to see how this circuit works. Well, first we will start with the USB socket. As you can see, you have a USB socket. Now, even the same USB mobile charging cable will come in handy here. Find an old USB socket that you no longer use, cut off its wire, and have the socket like this. When you look at the socket head and strip the wire, you will see 4 wires as you see here, which are usually 1 black and 1 red, green, and white in the standard mode. Now, it doesn't matter if there are other colors. We are dealing with black and red, which are actually USB voltages. This means that when you connect this socket and USB to a USB input, such as a power bank input, the black and red wires receive a voltage of 5 volts. We don't care about the other 2, whatever color they are, which are white and gray here, because these are data wires. We don't need data wires in this project, so we'll cut them off. If I use a wire cutter, I will cut off the extra wires, and there are 2 wires left that we need. Now to increase the length of my wire a little bit, I'm going to add another wire to this wire. I brought a black wire here to connect to the black part. Now, because I'm giving a tutorial, I don't have time to do this. But when you screw the wire together, make sure to use solder to make sure your connection is strong. Then I use red wire for the positive side to increase the length of the wires. And then I connect these connection parts with a wire connector. I use 2 wire connectors, 2 pieces of wire connectors. You definitely have to do this. 1, I apply the first and second varnishes, and then I heat the varnishes using a heat gun. And in this way, the wires will be fully connected. Well, in order to be sure of my connections, when I strip the ends of the wires, I will measure the voltage with the help of my friend. I will use 2 Sosmari sockets. I put the multimeter in DC test mode. The black socket connects to the black prop and my red wire goes to the positive prop side. The multimeter is in DC mode and I connect the proper to the USB using this Maria socket. Now if everything is correct, by connecting the socket and the USB to the power bank, I should see a voltage of 5 volts on the multimeter. So as you can see, I'm seeing 5 volts here. If you plug in the socket and you don't see any voltage, be sure to remember to turn on the power bank. There's a switch here. By holding the key on the power bank, we can turn on the power bank. So I have 5 volts here. It's true that 4 volts are missing, but it's about 5 volts. Of course, when the power bank is charged, this voltage reaches the 5 volt point. The connections were correct. Now let's move on to the next step. The next step is to use the boost module. These boost modules boost the output voltage relative to the input, meaning you can give it a voltage, for example, 5 volts, and here you get the voltage you want. As you can see, this module has an output section marked with the symbol at. At is positive, at is negative, and the input side of the voltage is negative. And we see this positive here. So that means we have to give the output voltage of the power bank to the input of this module. So we will also connect the positive wire to the positive side of the socket and the negative wire to the negative side of the socket. Okay, let's make the connections. And then I'll glue these connection parts. Now I'm using electrical tape here to make the tutorial go quickly. But I suggest you still use varnish, which provides a quick clean seal. So my efforts are done and the result is what you see here. Our USB socket is connected to the modem input, and now we need to connect this USB to the power bank. Now we need another socket. To connect to the modem, you need to see what socket input your modem uses. Most modems have a male adapter jack, meaning the socket you see here can be purchased from any electronics store. As you can see, these sockets are a quick one that connects to the modem, with the outer body being negative or E undiode, and the inside being positive, or BC say. Most sockets that you buy are clear about which wire and which growth the negative and positive are connected to. But for a more accurate test, I recommend using a multimeter. We put the multimeter in the test mode and connect the negative probe to the body of this socket and with the other probe. We test the wires to see which wires it is touching, and we will find out that it is the negative wire. We test it and it does not touch this probe, so we will find that this strand of our wire is negative, and you can mark it. A socket that I use has a white thread and a completely black thread. It is clear that the one that does not have a white thread is negative. These colors may be different. This way you will find out which side and which thread is connected to the coil or the positive. We don't have to do anything anymore. Use the multimeter. We return to DC test mode. Now, what we need to do is connect the negative and positive sides to the output of this module. I connect the positive to the red wire and the negative to the negative wire. And again, I fix the connections using glue. After doing this, I finally have a structure like this, and in order to make it neat, I can collect the wires. And finally, you see a structure like this here, input and output. Now let's see what our output voltage should be. That is, what output voltage should we have? The voltage we need to turn on the modem is usually between 9 and 10 volts. But most modems, according to our experiences, and the ones we use now, are 9 volts. So we should increase the 5-volt voltage to 9 volt. But I suggest that in order to know the working voltage of your modem more accurately, it is enough to remove the modem. I brought a LAN modem here. Now, it doesn't matter whether your modem has a Wi-Fi system or not. We don't care about the capabilities of the modem. We just want to turn on a modem. I brought a LAN modem here that we use in the electronics workshop, and we must definitely see its working voltage. Sometimes the working voltage is written on the modem label. Sometimes it is written in the input socket, which in this modem is written in the input socket, as you can see. The input is 9 volts, 1 amp, and if it says AC or DC, it doesn't matter, because these modems have their own converters. Even if you connect DC, it's true that it says AC, not volts, but we can also give it DC. When we give the voltage to the modem to make sure it works, we need to see if the modem turns on or not. When the modem turns on and then starts searching for a telephone line and excellent flashes, now depending on the mechanism of your modem. It's better to read the modem's instruction manual to see how to search for the internet. And when you see that it is searching for the internet normally, even though its socket is disconnected, it will naturally not find the internet. But when it reaches the search section and starts searching for the internet, it means that our circuit is working well and can supply power to the modem. You can keep your modem turned on and connect its internet socket, and according to you, can connect to the internet as usual. Now after you've made this power supply, you can consider a package or case for this power supply specifically for the modem. Place it next to the modem and plug the modem socket whenever it is needed. Connect it to the power supply you learn and build here and have internet access in some part of the device. Let's go to home or work internet. First, let's increase the voltage to 9 volts because our modem was 9 volts. Now for this, we put the multimeter in DC test mode. We will connect the multimeter to the power output for the foot. Any outlet that is here will be the same at the socket, and then I will plug the socket into the power bank. You will see that it will show the voltage of 5 volts. Now, using the multi-threaded thread located here, you will see that the voltage increases when you start multi-threading on the multi-threaded page. The voltage changes, so now it's 5 volts, and I'll keep turning it until it reaches 9 volts. So as you can see, it's up to 9 volts, and now we have 9 volts here, and then I can connect this socket to my modem. We'll need to measure the voltage because when you set it to 9 volts, This DC module keeps the voltage and output in the same state. Even if you turn the power on and off, i.e., remove the socket, then hit it again, and when you measure you will see that we will still have 9 volts. And as you can see, an important point, if you see that by disconnecting and plugging the socket into the power bank, the output voltage does not stay at 9 volts and fluctuate. The reason for this is that your DC-DC converter module is faulty, and this problem is usually not related to ISIS and the Kotham. The problem is related to the termination. In this case, you should be the termination. Replace this blue space you see here and in this image, and by providing a more durable material that usually breaks down quickly, you can restore stability to your space. Be careful not to. The output voltage of the amplifier should not be higher than the working voltage of the modem. Otherwise, your modem will burn out. Now that we have the voltage here, I will leave the multimeter as a precaution and see. Now that we have made the connections correctly, we will go to test it to see if it can turn us on or not. And I told you an important point about the module, and before we did the test, I want to tell you another very important point. That you are not required to use such a module to boost the voltage and convert 5 volts, and convert 5 volts or 9 volts or any circuit and module that can do this, and you can use it in such a project and in this tutorial. Unfortunately, the module that I am using here was introduced just now in this tutorial for convenience and ease of work and to convey the essence of the matter. But the module is not suitable, good and reliable for this task because our goal here is never to make a fake video, God forbid. So I tested at least 5 or 6 of these modules, none of which worked and could not turn on the modem. And one module was found among the 5 modules. I tested first, then I came and made this tutorial. Pay attention, you bought this module, and you saw this circuit you made that cannot turn on the modem. Don't come to a time when you want to leave a comment. It doesn't work for me. The videos were like this, and remember that I didn't serve the subject. These modules mostly have problems, and in many cases, they cannot have proper and long-term function. So since my goal was to teach a working circuit, I emphasize again that you should use better opportunities for this matter, and even make a circuit yourself that can. Step up to 5 volts, step up to 5 volts DC, and convert it to a voltage of 9 volts and 12 volts, which will be much better than these modules. Though if you see this circuit, it works. There is only one reason, that is the module from the discussion of the issues, which you should be very careful about the module itself as mentioned. This DC module has many problems with the model I wrote here, and in most cases it does not work. Now because I had found one of these, I tested it. So here you're going to turn on the modem, I say. We will put the socket in this way, and then the socket that I put in has a switch on the back. Now I want to turn on the switch and show you on the modem. I will tell you how it works. So I turned on the switch, and now you saw that the lights here turned on. So the red light came on. The status also turned on. Now we are waiting for it to search for A to SL, and its search light will turn on, which usually takes a few seconds, and it will start searching. If it reaches the search stage and this red light also turns off, it means that our power supply is working properly and was able to power the modem. If it stays in red, it depends on the modem model. For example, in our model, if this stays red, it means that the power supply is not suitable and cannot deliver the necessary power to the modem. And then we should check the power supply again. But we should keep one thing in mind depending on the modem model. As mentioned, these lights may have different state. For example, in the model that I'm using now, it will not start searching until the telephone line is connected to the modem and to the back of the modem socket. So when the telephone line is connected, the light will come on. My diesel will turn on here, so what I need to do is to connect the telephone line to it, which of course I don't need to do here anymore. And the goal was to see that the modem reaches the power on state, and now you see it is completely on. The green status means that the situation is completely okay. And the power supply was able to provide the necessary power to the modem. Well, that's it. And I'm turning off the modem now, and I tested this circuit, friends, and it works well and is okay. In another tutorial, we will try to teach you a much better module and teach you how to make a more professional DC to DC converter module. That can help you in several circuits, and don't use these bad modules anymore. So I have explained the important things so far. Now the other thing I want to explain to you is that if you have ever used such a module, it is better to put this module in a frame, or if you have found another circuit that has this size. Put it inside a frame and put that frame on the modem. Now it will be like a sky next to that modem, so that the input of the output is very stylish, so that it is not outside, so that at some point a bad connection will occur and cause the circuit to fall. And being inside the frame is much better. For example, we designed a frame for this module model, which you see here. It is completely compatible with small modules. And of course you can put other modules inside it. You can put all kinds of DC-DC exchanges of this size inside it. It has a spacer to close the module, which you put the module inside. And it also has a cap that you put and close the spacers inside it. And you can easily assemble a circuit inside such a case so that it is not outside so that once a connected bolt. There is also a place for wires here, so that you can pass the input and output wires through this part. You can also make this frame on the website. If you use a printer, you can also make this frame yourself, and so that you can easily follow. If you just want to buy the frame itself, I put the link at the bottom of the video description. If you have that printer and want to make it yourself, I have also put the file for you that you can download and make for yourself. And I have also put the link to the download file at the bottom of the video description. It is very versatile and is useful for such creatures that it has its own plastic spacer, and the screw that goes in is the M3 screw. And with these screws, the module inside is tightened and it stays really tight. When you buy this thing, both the spacers and the screw come with it, and you can use it easily. If you have downloaded the file, it already has it is a spacer, meaning all these spacers, the frame and the cover, are in the file. And when you print it with the printer, you can make it all for you. You just have to buy the M3 screw again. This is if you download the file. But if you buy it yourself, as mentioned, everything comes with it. This is also from this video. I hope this tutorial was useful for you. God bless you until another useful tutorial from the Electronic channel.